Today I'm going to be putting together a voltage and current sensor module for my data logging watt meter, and to make that I'm just using an ACS712 module and a 50k potentiometer, and this will form the voltage sensor. So I'm going to solder these together just now, and I'm going to configure it such that I will only need 4 wires, one for ground, one for supply, one for the current signal, and one for the voltage signal. It will take this sort of form factor here, so what will happen is just the top leg of the potentiometer will have the supply voltage, and the bottom will have ground, and also that ground will go to the ground of the microcontroller, and then the 5 volts will come out the middle. So it's going to look something like this when it's done. I will also remove the screw terminal too. So here we are so far. This module is bidirectional, so it can measure current in the opposite direction too, but what I would suggest doing is maybe scratching back some of the traces and beefing them up a bit with solder, because it's meant to take 30 amps maximum, and with 30 amps flowing through it, the traces would probably get a little bit warm and cause some energy to be wasted. But I'm going to scratch those back just now and solder them. So here's where I'm up to now. All that will need to happen is this leg of the potentiometer here will need to go to ground, which is just that bar going across there. Then this one will go to positive, just any one, that doesn't matter. And also just the ground from that bar will go into the ground to the microcontroller, and then this will be our output there, and that will just go out to a separate cable, which will go into another ADC pin. So I've just soldered that all together now. So here's where we're up to now. What I've done is I've just simply cut away a bit of the ground plane. I've just made it made a little pad there, so I've put one end of the potentiometer there, and the other end over on the right here just goes to the positive of the voltage to be measured, and the middle pin there, that's going to be the output signal. So I'm only going to need just 4. It'll just need 4 wires. So the output signal is going to be relative just to this ground pin here, and that should work fine. I just need to go and test it now to make sure that there are no short circuits. One thing I forgot to do was make that connection from the ground plane just to the negative supply rail there. So ground plane is just connected to negative, and that also goes into one end of the potentiometer, like so, and that's also just grounded to that board, and the other end goes onto the positive, and then I've just got pin header coming out there where the 0 to 5 volts will come. So I'll just have to cover this all in glue now, because I just tested it, there's no short circuits, and then calibrate it. So this is the completed module. All I did was cover it in glue and then heated it with a heat gun just to smooth the glue out. I did pre-calibrate the potentiometer before I actually built this, but I'll just do it again just in case I've bumped it, because even the slightest movement on the adjustment could throw it off quite a bit. So to calibrate it, you want to know what is the highest voltage you're probably going to be measuring, and then just add some headway onto that. So I want to be using this on my electric bike. So the battery is 44.4 volts, but it never reaches 50 volts. So that is going to be the in practice we're never going to see this voltage on the battery. So this is a upper range voltage. So now with 50 volts going into it, we're just measuring the output of the voltage sensor, so we want to adjust that until that reads exactly 5. And the movements you need on the potentiometer are absolutely tiny, so you have to have a very steady hand while you do it. But once you get that to exactly 5 volts coming out, then that's the voltage sensor calibrated. So that's the module now calibrated on the voltage side, and now I'm going to connect it up to the data logging wattmeter. It's just showing noise just now, it's not actually got any sensors connected to it. So here's my sensor connected, and we're getting acceptable readings just now. There's obviously a little bit of noise in the amps, that is normal according to the data sheet for the current sensor. I have had my wattmeter running for a little while now, and according to this, 1.77 watt hours has been transferred. I'm just using as a load this monitor and a router. That's all that's been powered off the power supply. But I think my meter is a little bit inaccurate, because according to this, this one's saying 2.2 watt hours and this one's saying only 1.84. And I've noticed that the current measurement on mine jumps about, well, the current and the watts jumps around a lot more than this one. So probably the software in this uses some sort of averaging to take out all the spikes and everything like that. And I think there's also an option on the sensor where you can change out the capacitor to get a smoother output. But I think mine already had the larger capacitor in it, so I think I'll go for the averaging option next. So it's been logging to an SD card, which is just plugged into a module that's hanging down there, so we'll take that out now and have a look at the data. So I've programmed it so that it just creates a CSV file on the SD card, and here is the data that I got out of it. The orange line is just watt hours, which will just slowly ramp up, and the blue one is just the watts. So the monitor and the router drew quite a bit of power when they started up, and then it just sort of shakes around quite a bit. But if I do some averaging, then I can maybe get it to appear smoother on the screen. But I'm still not sure about the current consumption. My multimeter showed about 0.7 amps average. This shows 0.65. So the multimeter and this are probably correct. So there's maybe just a little bit more calibration done, but this is where I'm up to on my project just now.